How is a gas inside a container? Take a look at this figure over here. I'll make zoom in. This is what we know as a piston, okay? Like the pistons that we used to have in hydraulics. It's the same, okay? Well, that's a piston, and the idea of it is that it's able, I don't know, you cannot see my screen, I mean my camera. So, let's see. No, I can't use the camera. So annoying. Maybe if I disable my, let's see how it works. Ding, ding, ding. No, it's still it's not working. So annoying and frustrating. Okay, I won't complain. I won't complain. Okay, so the idea is using the iPad, and that's it. The idea of the work done on a system on a gas is, take a look. Well, loading. It says loading, 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 and that's it. Okay, well, I'm gonna use the computer. So what happens here? Inside, just imagine, pretend that here, all I have is a gas, okay? In that container, all I have is gas. So if I apply pressure here, if I apply pressure over there, okay, just imagine you are applying pressure, or you're just pushing the piston down, in other words. Okay, what is going to happen? Just imagine what is going to happen if you apply some pressure bueno, qué barbaridad. Just imagine that you are applying some pressure over there. What is going to happen with the piston? The piston is this one, remember? Okay. In what direction is this going to move? Is it going to move upward or is it going to move downward?
Downward, miss.
Well, thank you. So if you apply pressure here downward, what is going to happen is that the piston is going to move also downward, okay? So the position of the piston changes. And what's going to happen? Now, just imagine this is the actual position now. Just imagine. What is going to happen with the gas particles that are inside? How are those particles going to be? Are going to be closer one to another? Are they going to be more separated? How are they going to be? Closer or more separated?
Closer.
It's going to be closer, okay? If they're closer, what happens? If you are next to someone with all this temperature, the summer temperature, what is going to happen? How do you feel? How do you feel the temperature? The temperature rises or decreases? When you're closer to a person, very close to a person, How do you feel the
Rises.
temperature? Increases,
Rises
okay? You
me.
feel desperate because that person is so close to you. You're desperate because you can actually feel his temperature, his body temperature, and it gets warmer. That is because particles are closer one to another. When they are closer one to another, we apply the concept of the kinetic energy. The particles start to collide. I mean, they're going to collide because they are going to move faster. If they move faster, the temperature increases. If the temperature increases, what is going to happen inside? The pressure also increases. Okay, so what is going to happen? You have to make an analysis of all that every time that we work with a gas. Now imagine the situation is that here inside this container we have so many particles of gas. And what happens? The temperature increases, of course. Okay, if the temperature increases, the particles are moving faster, the temperature increases. Now here in the container, after those particles are colliding and moving in that way, they are going to produce something, that is, that they are going to push away the piston. Okay, so the piston is no longer pushing the particles down. The particles now are fast enough, strong enough to lift the piston. So the difference in the two situations that I just told you about, when you have your pressure applied on the piston, what happened with the gas? The gas undergoes what we know as compression. Okay, the particles get compressed because you are applying the pressure down. Okay, but what happens when the particles are strong enough that they lift, that they are able to lift the piston? What happens? Expansion. Okay, so these situations, the two situations that I told you about, refers to the two type of works that can be done by a gas. If a gas undergoes compression, means that the work is done on the gas. If the work expands, if the gas expands, that means that the work is done by the gas. Just imagine the pressure, you apply the pressure, you push the piston down. You are working literally on the gas. The piston is on the gas and the piston is pressing the gas down. That's why this compression, it refers to a situation where the work is done over on the gas. But when the gas is strong enough to lift, okay, when the gas is strong enough to lift the piston, okay, who is making the work? The gas. So this is a very big difference between the two kind of work. Those are the two kind of work done by a gas: compression and expansion. Expansion is done by the gas and compression is done on the gas by another person, for example, by a machine, by any other means, but not by the gas. But when expansion occurs, that work is done by the gas. And what equation are we going to be using? The same. Work is done, or work is equal to force times distance. But we need to make some adjustments, okay? Work, okay, is equal to the force times the distance. But right now, because we need to involve, or we need to get included some areas, okay? Because you know that when we work with pistons, we usually work with transsectional areas, like we used to work in continuity equation or hydraulic lift, okay? So what happens here? The equation changes, okay? The equation changes, and just remember, here, what happens here? Area divided by area. If I put a 2 divided by 2, this is 1. If you have your area divided by area, this is 1. So here your equation is only making use of the areas in a way that we can change the equation, but it's not altering the main equation. Here, the main equation is force times distance. It's the same right here. If you multiply the force times distance times 1, it's going to give you the same. Just imagine that area divided by area is a fraction. Same number in the top, same number below. So this is the same as multiplying or as having force times distance times 1. So what happens here? I'm not altering anything, okay? I'm talking about the same equation. But this allows us to make some adjustments in the formula. And what happens? If you multiply this, if you multiply all this, you can say, okay, I know that force divided by the area is a concept that I know already, that is pressure, okay? And what is missing after dA or AD is the same, okay? So what happens when you multiply area times distance, or area times distance? It's just another way to say volume, okay? So in this case, force divided by the area, you know this is pressure. And area times the distance, you know this is volume. And this is how the equation work equals pressure times volume comes from. Now with this, I'm just telling you that sometimes you are going to be using this equation. If the pressure is provided and the volume is provided, you can use directly this equation. Or you can also use this equation in the case that the problem gives you the force. Now, in what units do we measure the work? Work is measured in joules, okay? Just remember that work is measured in joules. And just remember that 1 joule is equal to 1 Newton meter. Just remember that. Now let's take a look to this sample problem for you to see that it's very, very easy actually. An engine cylinder has a cross-sectional area. As I told you, when we work with pistons, we work with cross-sectional areas. So the engine cylinder has a cross-sectional area of 0.01 or 0.010 meters square meters. How much work can be done by a gas in the cylinder if the gas exerts a constant pressure of 7.5 times 10 to the fifth power pascals on the piston and moves the piston a distance of 0.04 meters. So what we do with this sample problem? First, we need to get the givens. So we gather the givens And again, I'm going to start from the beginning. First, they are giving me the cross-sectional area, or just the area, okay? So let's write the givens. They're giving me area of 0.01 square meters. How much work can be done by a gas? So this is what the problem is asking me to find. How much work can be done by a gas? So work, it says by a gas. If it is work done by a gas, what is it? Expansion or compression?
Expansion.
Okay, it is expansion. Okay, just by a single word, I know what that kind of work. Okay, so this is expansion. Now it says, if the gas exerts a constant pressure of 7.5 times 10 to the fifth pascals on the piston and moves the piston a distance of 0.04 meters. So the problem is giving me the pressure that is 7.5 times 10 to the fifth power pascals, and it's giving me distance of 0.04 meters. So what is the problem asking us to find? Is asking us to find the work. Now let's take a look to the equation of work just to get familiar to what can we use and how can we make the arrangements. It says work is equal to pressure times volume change. But I gave you a formula for volume. Take a look. This is important because you can use this here, okay? I told you that area times distance is equals to volume, okay? So how can we work with this? First of all, we have the main equation. That is work equals pressure times delta V, okay? The pressure, you already have it, but you don't have delta V. What do you have instead? You have distance and you have area. But guess what? When you have distance and area, it's actually the same as having delta V. So what I do right now is I'm just going to replace delta V by its meaning, that is D times A. So I say work is equal to pressure times distance times area. Okay? Just remember, distance times area is the same as delta V. It means the same. Now, we just substitute by the givens. Okay? We say the pressure, that is 7.5 times 10 to the fifth power pascals, times the distance, that is 0.04 meters, times the area, that is 0.01 or 10 square meters. So work is equal to what? We just multiply. How much is that? Guys?
300. 300.
300. In what units do we measure work? I told you.
Joules.
Joules. So 300 joules, and that is the final answer. As you can see, it is very easy. You just need to apply the formula. Okay. Okay, I'm gonna work with another one. That's it. I mean, that's all the exercise done. This is another problem, okay? It says the cross-sectional area of the piston in figure 1.2. This is the figure 1.2. Okay, I'm gonna put it here. So it says the cross-sectional area of the piston in the figure 1.2 on the previous page is 0.20 meters square meters. A 400 Newton weight pushes the piston down 0.15 meter and compresses the gas in the cylinder. How much pressure is exerted on the gas? By how much did the gas volume decrease? So here in this problem, we have very interesting things, okay? So we are talking about, I'm gonna put that this is the figure 1.2, okay? So here, the problem tells you about the cross-sectional area that is 0.20. So you write your given. The area equals 0.20 square meters. Now it says a 400 Newton weight pushes the piston down. So the 400 Newton, we're talking actually about force. How do I know it's force? Because it's in Newton, okay? Pushes the piston down and it says, pushes the piston down 0.15 meters. So that means a distance. The distance, just imagine, now picture the situation. You are applying a force of 400 Newton here. So what happens? The piston is moving down, okay? Also the piston is moving down and now imagine is here, okay? So what is the distance that the piston moves? 0.15 meters. It pushes down the piston 0.15 meters. Now what else does it say? And it says, and compresses the gas in the cylinder. So because we have compression, the problem is telling you that we have compression, okay? Because it says compresses the gas. So how is this work done? Is it done by the gas or on the gas? On or by the gas? Take a look at the example, okay? What happens when we have compression? The work is done on the gas, okay? I gave it to you in the beginning, so you just put it as a part of the information. So it's work on the gas. Now, how much pressure is exerted on the gas? They're asking me to find pressure. How much pressure? And by how much did the gas volume decrease? Gas volume decrease or expand? Okay, any of those words represents a change in volume. And if you have a change in volume, it's just delta V. That's what it represents, okay? So they're asking you about the pressure and gas volume decrease. As I told you, this represents a change in volume or delta V. So delta V is unknown. And the pressure also is unknown. So what do we know about the gas? Well, we have the formula, okay? We have the formula, the main equation that is work is equal to, okay, according to what we have, as you can see, we have force involved in this problem. Because we have force, we better use the equation that has the force, okay? So what is the equation that involves the force? Is this one, the one in yellow. Okay. So remember, I'm just going to put the main equation: pressure times delta V. Sorry, you're not seeing. Pressure times delta V. Okay. You know pressure is equal to force divided by the area. And delta V, you know delta V is equal to area times the distance. I didn't write the distance, but it was given. Sorry, I just pointed out there, but I didn't write it. Distance is 0.15 meters, okay? So we have everything that we need. But we need to answer the question. So to find the pressure, just apply the formula of the pressure, okay? Pressure is equal to force divided by the area. So 400 Newton divided by 0.02 square meters. How much is this? How much is the pressure?
20,000.
20,000. In what units do we measure pressure? Pressure. Remember, under pressure, pascals. Okay? Take a look. Pressure. Pressure here is in pascals. So here is 20,000 pascals. Okay? Now, it tells you about the gas volume decrease.
Miss,
So,
Miss, I think you confused in the givens because he's 0.20 and he's 2,000, not 20,000.
ah, okay, sorry. It's true. I got confused here. I just put 02. So yes, it is 2000. Sorry, 2000 pascals. And what happens now? We can get delta V. I gave you already a formula for delta V. I'm gonna move this because, okay, like this. And this is called change in volume, okay? When I talk to you about change in volume, you don't remember that change is delta, okay? So that's why I put it like that. Delta V is equal to area times displacement. The area is given in the problem as 0.20, not 02, thank you, square meters, times the distance that it was compressed, that is 0.15 meters. How much is this? How much is this? Did you get the same answer?
Yes.
Okay. So delta V is 0.03 meters, cubic meters. But the problem is not that's it. We already solved the problem. But what if the problem asks you, what is the work done? Okay? Just imagine that the problem asking you about the work. How can you get the work? By using the equation, okay? By using the main equation, that is work equals pressure times delta V. You already know the pressure because you just got it. You already know delta V because you just got it, okay? So W is equal to the pressure, that is 2000 Pascal, not 20,000, and delta V, that is 0.03 cubic meters. How much is this? How much is
60.
this? 60. and the units are joules. Okay, just imagine that the problem is asking you about the work. That's how you should look for it. So with this, already know how to do. If the pressure is not given, you can get it by dividing force by area. Just remember that the force should be in Newton and the area in square meters. How can you get a change in volume? Change is equal to delta, okay? So when I say change in volume, I'm talking about delta volume, delta V. And that is an equation to get it, area times distance. Just remember, make sure that you have meters and meters, okay? So if you need to do a conversion, do it. Now, what's another thing that can happen in this kind of problems? That they tell you that there is a piston, okay? That has a radius or a diameter, 2 inches, for example. So what's gonna happen there? From the radius or from the diameter, you have to do the process that I told you in hydraulic lift, okay? From diameter to radius, from radius to get the area, okay? And the area of a circle, remember, is equal to pi r to the second power. That can also be a requested thing in this kind of problems. So you're gonna be doing a homework, but I'm not going to assign it today because I want it to be focused on today's quiz. Any doubt?